Okay, let's give you guys some more practice. So here we've got a magnet placed near a metal sphere, and the force that exists between them is inversely proportional to the square of the distance. Okay, so yeah, so the closer you have the magnet to the metal sphere, the stronger the force. If you move the magnet away, then the force will get weaker. Now the unit of force is measured in newtons. Okay, don't worry about this too much. The measure of force is in newtons here, Newton here. Yeah, don't worry about this unit too much. Your science teacher will explain it to you. But a force is just a push or a pull, and we need a way to measure the strength of that push or that pull, and the unit is measured in newtons. Okay, so well anyway, read the questions and answer the well, read the questions and answer them. Okay, so press pause and have a go. Okay, so here the you're given this. The force here um, is inversely proportional to the square of the distance. So you well, by that one sentence you can summarize the whole thing as this: the force is inversely proportional to the square of the distance. So you see that first sentence here. You can summarize it as this. Okay. So to answer to answer question A here, hang on. So we summarized it as that. So so here we summarized it as this: the force is inversely proportional to the square of the distance here. And once you summarize this here, you inside your mind you can visualize the graph here. This purple line is if you have a force that is inversely proportional to just the distance, not the square of the distance, but just the distance, it will look like this. But here you've got a force that is inversely proportional to the square of the distance. So you see this black line here, the force gets weaker a lot faster as you increase x. Now this purple line here is like this 1 over x, but our black line here is 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 inversely proportional to the square of the distance. So it gets weaker a lot faster. Just imagine what would happen if you have something like this 1 over uh, a force is inversely proportional to the cube of the distance. It would get weaker. The force would get weaker a lot faster as you increase the distance. Well, anyway, once you've summarized the situation into this form here, visualize your graph, and also you can visualize this. Okay, and also you can visualize this. Now, when you have this kind of a relationship here, what it means is if you times x by 2, then you would decrease the force by 4. Okay, you divide it by 4. If you times this by, let's say, 5, then you would decrease the force by 25. So here you have to divide it by 25. It's that kind of a relationship. So once you're here, you can you can also visualize this thing here, and this is your task here, to find out this equation. Once you've got this equation, you can you can answer questions B and C easily. So question A is asking you to find the relationship between the two, and it's given you the initial condition here. This here, the distance between them is this, and the force is this. So you can use the initial condition here to find out your k. So you put the hang on, you put the distance into the x, okay, and then you put this 0.8 into the f here to find out your k here. Sorry, yeah, okay. So put it in. So this here is your distance, square it, and this here is your force. So here when you square this, it becomes this here, and then what you do when you're here, times both sides by this bubble here. That will give you k. that will give you this k here. So once you've got your k, you can just put this into this here, and then you will have your equation, okay, which turns out to be this, here. So this is the answer to question A, okay. And question B, hang on. So hang on, let me just get rid of question A. Question A. Now question B here. Now B, well earlier we just worked out our equation, which was this here. Now once you've got your equation, you can easily work out, find the force when the magnet is blah 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 away from the sphere. So this is your distance. So you can put this into the distance here to find out your force. Once you've got the equation, it's easy after that. So this is your distance here. You've got to square it, and then it becomes this, okay. And then to find out the force, then it's just basically this thing divided by this thing. Get your calculator and get 0.018 divided by 0.0289, and then that will give you 0.62. And because we're talking about force, it's measured in newtons, so it's going to be that, okay. So that's question B done. C, hang on. C here. So from question A, we've got our equation here. Now the question C is saying find the distance when the force is this. So here you just put the force into the F. Okay, so that will give you this. Put the 25 into the F, and then it's a matter of finding out X here. Okay, so here square times X squared to both sides. Okay, so it becomes this. Now, yeah, so times X squared to both sides. So this X squared here moves across here. So it becomes this here. And now divide both sides by 25. So that will give you X squared equals this. And then, well, to find out X, then you square root both sides. Okay? So, well, jump to your calculator and work this out for yourself. So X here equals this. Okay?